In question 1, we are asked to find the integral of 2x minus 5 times 3x plus 2 times 2x plus 5 with respect to x, and we need to give our answer in its simplest form. Well, I will actually start by expanding the triple bracket here to see exactly what we're dealing with. So I've got 2x times 3x is 6x squared plus 4x minus 15x minus 10 close brackets times the 2x plus 5. I will collect like terms, so we're looking at 6x squared minus 11x minus 10 multiplied by 2x plus 5, and I will further expand this to get 12x cubed plus 30x squared minus 22x squared minus 55x minus 20x minus 50, which simplifies to 12x cubed plus 8x squared minus 75x minus 50. This means I can now proceed into integrating 12x cubed plus 8x squared minus 75x minus 50 with respect to x, and we know that in integration we are increasing the power by 1, dividing by the new power. So I've got 12x to the power of 4 over 4 plus 8x cubed over 3 minus 75x squared over 2 minus 50x plus c, where c is the constant of integration. The only thing missing is for me to simplify the 12 with the 4, leaving me with a 3 in the numerator, and therefore the final answer is 3x to the power of 4 plus 8x to the power of 3 over 3 minus 75x squared over 2 minus 50x plus c. In question 2, we've got triangle ABC with AB being 15 centimeters, AC being 25 centimeters. The angle BAC is given to be theta degrees, and the area of this triangle is 100 square centimeters, and we need to find the value of sine theta. So let me start by drawing a triangle here. This is the information we're given. Well, we know that the area of a triangle is given by a half AB sine C. So in our case, the area is known to be 100, which is equal to a half times the 15 times the 25 times sine theta. So this leads to 100 being equal to 187.5 sine theta. So if I divide both sides by 187.5, we get 100 over 187.5 being equal to sine theta. And the left-hand side simplifies to 8 over 15 for sine theta. Notice that we do not need to find theta. We need to stop when we find sine theta. In part B, we are told that theta is greater than 90, and we need to work out the length of BC to 3 significant figures. So let's start by saying that theta is shift sine of 8 over 15. This gives an answer of 32.23095 ... However, we know that theta is greater than 90. We've been told that it's an obtuse angle, which means that theta is 180 minus the 32.23095, which gives an answer of 147.769. And therefore, we can go back to the triangle. We can add the information which was found. This is 147.769. We're trying to find BC, so the idea is to use the cosine rule because we've got the two sides here and the included angle. Now recall that the cosine rule says that a squared is b squared plus c squared minus 2bc cos a. So in our case, we've got bc squared is 15 squared plus 25 squared minus 2 times 15 times 25 times the cosine of 147.769. If we plug in everything on the calculator, we get 1,484.42887. And if we simply take the square root of this, we get 38.5 centimeters for the length of BC. In question 3, we've got the curve C defined here, and we need to find dy dx, giving our answer in its simplest form. Well, the first thing we need to do is take the expression for y. It's 5x cubed minus 8 over 2x squared, and we need to put it in index form. So this is 5x cubed over 2x squared minus 8 over 2x squared, which simplifies to 5 over 2 times x minus 4x to the minus 2, and therefore dy dx, remember in differentiation we multiply by the power and then we deduct 1 from the power, so it's going to be 5 over 2 minus 4 times minus 2x to the minus 3, which simplifies to 5 over 2 plus 8x to the minus 3. In part B, we're given that the point P with coordinates 2, 4 lies on C, and we need to find an equation for the tangent, giving our answer in the form ax plus by plus c is 0, where a, b, and c are integers. Well, I will start by evaluating the expression we just obtained for dy dx at x is 2. This will give me the gradient of the tangent. So we're looking at 5 over 2 plus 8 times 2 to the negative 3, which gives an answer of 7 over 2. This is the gradient of the tangent. And to proceed to find the equation of the tangent, I will be using y minus y1 is mx minus x1. So in our case, we've got y minus 4 is 7 over 2 brackets x minus 2. So we can proceed into cross multiplying 2 brackets y minus 4 is 7 brackets x minus 2. So if I expand, I get 2y minus 8 is equal to 7x minus 14. And then collecting everything on the left-hand side leads to 2y minus 7x plus 6 is 0, which is the final answer in the required form. In question 4, we need to show all stages of the working, and solutions relying on calculator technology are not acceptable. Well, we need to substitute p is 2 to the x into the given equation here to arrive at this quadratic in p. So starting with p is equal to 2 to the x, we can say that 4 to the x is 2 squared raised to the power of x, which is 2 to the x raised to the power of 2, and therefore it's p squared. Well, we've got 2 times 4 to the x minus 2 to the x plus 3 is 17 times 2 to the x minus 1 minus 4. We said that 4 to the x is simply p squared, and I will split 2 to the x plus 3 as 2 to the x times 2 to the 3, and this is equal to 17 times 2 to the x times 2 to the minus 1 minus 4, which means we're looking at 2p squared minus 8p is equal to 17p times a half minus 4. I will then multiply everything by 2 to get rid of the denominator of 2, which leads to 4p squared minus 16p is 17p minus 8, and I will be collecting everything on the left-hand side, leading to 4p squared minus 33p plus 8 is equal to 0 as required. In part B, we are asked to hence solve the given equation. So starting with the given quadratic, we need to show all the working clearly. I cannot use the calculator to extract the solutions to this quadratic, so I will instead proceed with factorizing. We've got 4p minus 1 times p minus 8 is equal to 0, which means that either 4p minus 1 is 0 or p minus 8 is equal to 0. So we're looking at 4p is equal to 1, which means that p is a quarter, or p is equal to 8. Well, we know that p is 2 to the x, so we've got 2 to the x is 1 over 4, and 1 over 4 is 1 over 2 squared, which is 2 to the negative 2, and therefore x is negative 2 is one solution, whereas for p being equal to 8, we've got 2 to the x is 8, which is 2 to the power of 3, and therefore the second solution is that x is equal to 3. In question 5, we've got the straight line L1 shown here, passing through the points P with coordinates negative 2, 9 and Q, 10, 6, and we need to find the equation of L1, giving our answer in the form y cos mx plus c. Well, we know that the gradient is given by y2 minus y1 over x2 minus x1. So in our case, we've got the gradient being 6 minus 9 over 10 minus negative 2, which gives an answer of minus a quarter. And knowing that the equation of the straight line is given by y minus y1 is mx minus x1, we can proceed into y minus 6 is equal to minus a quarter brackets x minus 10. I will expand this to get y minus 6 is minus a quarter x plus 5 over 2, which leads to y is minus 1 over 4x plus 17 over 2. We are then told that the straight line L2 passes through the origin and is perpendicular to L1, and the two lines meet at the point R, and we need to determine the coordinates of R. Well, we have established that the equation of L1 is y minus a quarter x plus 17 over 2, so we know that the gradient of L1 is minus a quarter. This means that the gradient of L2, which is perpendicular to L1, is simply 4. So the equation of L2 is simply y is equal to 4x since it passes through the origin. Now I will be equating the two straight lines in order to find their point of intersection. So we're looking at 4x is equal to minus a quarter x plus 17 over 2. I will multiply throughout by 4 to get rid of the denominators. So we're looking at 16x is equal to minus x plus 34. So 17x is 34, which means that x is equal to 2. And I can proceed. Y is 4 times 2, which is 8. And therefore we conclude that the coordinates of the point R are 2, 8. In part C, we're asked to find the exact area of triangle OPQ. Well, we have found the coordinates of P, R, and Q as shown here, and we're asked to find the area of the triangle shown shaded here. We know that the base will be the distance of PQ, and the height will be the OR because the two lines are perpendicular, so this is a 90-degree angle. Well, let's remind ourselves that the distance between 2 points is given by y2 minus y1 squared plus x2 minus x1 squared and all square root. So the distance PQ here is going to be equal to 6 minus 9 squared plus 10 minus the negative 2 squared and all square root. This gives an answer of 3 root 17. This is the base of the triangle. Now for the height, that's going to be OR, which is going to be 8 minus 0 squared plus 2 minus 0 squared and all square root. This gives an answer of 2 root 17, and therefore we can conclude that the area of triangle OPQ is going to be 3 root 17, which is the base, times 2 root 17, which is the height, over 2. So I'm doing base times height over 2. And this gives an answer of 51 units squared. In question 6, we are given a plot of y is 5 cos x. X is in degrees. And we need to state the coordinates of point P. The point P is here. Well, let's start by considering the effect of this transformation. The 5 there means that we multiply y by 5. So if we recall the graph of cos x, it looks something like this. The first minimum is at 180, negative 1, and the next minimum is at 540, negative 1. It's 360 degrees later because the period of the cosine wave is 360. If we look at the graph here, it's the second minimum point, and therefore we need to consider the effect of the transformation on the point with coordinates 540, negative 1. Well, if we multiply the y by 5, we end up at 540, negative 5. We're then told that the point Q lies on a different curve C2, and the point Q is a maximum point on the curve with the smallest x coordinate, with x being positive. And I need to determine the coordinates of point Q in the case where y is 5 cos x minus 2 and y is minus 5 cos x. So let's start by recalling the graph of cos x. We've got a maximum at 360, 1. So if we consider y is 5 cos x minus 2, the transformation is essentially multiplying y by 5 and then deducting 2 from y, which means that the maximum point of 360, 1 will now be at 360,3. We multiplied the 1 by 5, leading to 5, and then we deducted 2, so we ended up at 360,3. Now in the second part, we've got y is minus 5 cos x, so this means that we multiply the y values by negative 5, which is essentially a reflection along the x-axis combined with the scaling, with the stretch of a scale factor of 5 along the y direction. So we will see that the graph will look something like this. So we've got this reflection and also the scaling by 5. So the maximum here will be 5 and the minimum will be -5. Notice now that the minimum points will become maximum and the maximum will become minimum, and therefore this means that the coordinates of the maximum point will stem out of this minimum of 180, -1. If I multiply the y value by -5, this takes me from 180, -1 to 180, 5. In question 7, we are asked to sketch y is 4 over x minus k, where k is a positive constant, and we need to show the coordinates of any points that we cut through the axis, as well as the equation of the vertical asymptote. Well, let's start by considering the cut on the y-axis. This means I will be putting x to be 0, and therefore we're looking at y is 4 over 0 minus k. So this is minus 4 over k. We've got the cut on the y-axis. Now we know that this minus 4 over k will surely be negative, since k is given to be a positive constant. So we are cutting the y-axis at a negative point. We will then proceed with the equation of the vertical asymptote. So we know that we've got a problem when we divide by 0 when x minus k is 0. So if x minus k is equal to 0, this means that the equation of the vertical asymptote is x is k. And we also know that we've got a horizontal asymptote. So to find the equation of the horizontal asymptote, we consider the behavior of y as x tends to infinity. So as x grows larger and larger and larger, we've got 4 over infinity. So this is pretty much 0. So as x goes to infinity, y tends to 0. And therefore we conclude that the equation of the horizontal asymptote is simply y is equal to 0. This means we can proceed into sketching. We've got the x and the y-axis. We've got the vertical asymptote at x is k. And we've got the cut on the negative y-axis at minus 4 over k. So this is the graph of y is 4 over x minus k. We are then told that the straight line with the equation y is 9 minus x does not cross or touch c, and we need to determine the range of values of k. So we are looking at the curve y is 4 over x minus k and the straight line with the equation y is 9 minus x. I will start by equating the two as if I was trying to find their point of intersection. So 4 over x minus k is equal to 9 minus x. I will then proceed into cross multiplying. So 4 is equal to 9 minus x times x minus k. I will expand the right hand side to get 9x minus 9k minus x squared plus kx. So I will be collecting everything on the left hand side, leading to x squared minus 9x minus kx plus 4 plus 9k is equal to 0. And I will put this into a quadratic equation form. So we've got x squared plus x times minus 9 minus k plus 4 plus 9k is equal to 0. Now we know that if a line does not cross or touch the curve C, this means that the discriminant is negative, so b squared minus 4ac is less than 0. And in our case, we've got that a is 1, b is the minus 9 minus k, and c is the 4 plus 9k. So I will start by considering the discriminant, which will eventually lead to a quadratic in k. So to calculate the discriminant, I'll be doing b squared, so minus 9 minus k all squared, minus 4 times 1, which is the a, times the 4 plus 9k, which is the c, and I will expand this to get 81 plus 18k plus k squared minus 16 minus 36k. If I collect like terms together, I get k squared minus 18k plus 65, and we said that we want the discriminant to be negative, so this is less than 0. Well, I can factorize the given quadratic expression in k, leading to k minus 5, k minus 13 being less than 0, which means I can proceed in finding the critical values, which are the values that make the left-hand side 0. We've got k minus 5 is equal to 0, or k minus 13 is equal to 0, so k is 5 or k is 13. So if we plot this on a parabola with the critical values at 5 and 13, we see we go plus, minus, plus, and we want this to be less than 0, so I want to be in between the critical values, so my final answer will be 5 less than k less than 13. In question 8, we've got the sketch of the plan view of a platform. We are told that the angle AOB is 0.8 radians. The length of the arc CD is 9 meters and DA to AO is 3 to 5. And we need to show that the distance AO is 7.03 meters to 3 significant figures. Well, let me start by adding the information I've been given on my diagram. So we know that the angle is 0.8 radians, the arc length is 9 meters, and if the ratio of DA to AO is 3 to 5, this simply means that DA is 3 over 8 of the full distance and AO is 5 over 8 of the full distance OD. Now we know that the length of an arc is given by r theta when theta is in radians. So in our case, the length of the arc is 9, which is equal to 0.8 times the distance OD. So this means that OD turns out to be 11.25, and we can proceed in saying that AO, the distance AO, is simply 5 over 8 times the distance OD. So this is 5 over 8 times the 11.25 we just found, which gives an answer of 7.03125, which rounds to 7.03 to 3 significant figures as required. In part B, we need to find the perimeter of the platform in meters to 3 significant figures. Well, we know that the angle is 0.8. We have established that the distance AO is 7.03125 and the CD is 9 meters. Well, to find the perimeter, we certainly have the arc CD, so shown shaded here in red. Then we've got the two parts here shaded in blue, so this is 3 over 8 of the full distance, and we've got exactly the same part BC here. And then we know that this angle here is 2 pi minus 0.8, so we need to add the length of the arc AEB. So let's start by finding the distance AD. Well, AD is simply 3 over 8 times 11.25, which gives an answer of 135 over 32. And for the arc AEB, I will simply be doing 7.03125 times 2 pi minus 0.8. Again, I'm using that the length of the arc is r theta, so this is 38.5536 ... So the perimeter will simply be the sum of these distances. So it's going to be 2 times the 135 over 32. This is the blue parts. I've got two identical such parts. I've got the 38.5536 ... and the 9. If I add them up, I get 55.991 ... which means that to 3 significant figures, it's going to be 56.0 meters. In part C, we are asked to find the total area of the platform in square meters to the nearest whole number. Well, let's start by reminding ourselves that the area of a sector is given by a half r squared theta when theta is in radians, and this is the shape. We're trying to determine the total area, so we can see that this is consisting of 2 sectors. So we simply need to add the areas of the 2 sectors. So I will simply do a half times the 11.25 squared times the 0.8. This is the area of the sector here, the OCD sector, plus a half times 7.03125 squared times the 2 pi minus 0.8. This gives an answer of 186.165 ... which is of course 186 square meters to the nearest whole number. In question 9, we are told that C1 is a quadratic curve with a maximum turning point at 220 passing through the origin, and we need to sketch this graph showing the cuts on the coordinate axis. Well, we know that we have a maximum at 220. We're passing through the origin, so it should look something like this. And then we exploit the symmetry. We know that the line of symmetry is here. So if we're cutting the x-axis at the origin, we should also be cutting here at 4. So this completes our sketch for part A. We're then told to find an expression for f of x, so I will exploit the fact that I'm cutting the x-axis at 0 and 4, and I will say that f of x has a form of kx times x minus 4. So this is forcing cuts on the x-axis at 0 and 4. I will then use the fact that f of 2 is equal to 20, which leads to 20 is 2k times 2 minus 4. So we've got 20 is 2k times negative 2. So 20 is minus 4k, which means that k is negative 5. So f of x is equal to minus 5x times x minus 4. Alternatively, I could have used the fact that we've got a turning point at 220, so I could say that f of x is equal to a times x minus 2 squared plus 20. This is forcing the turning point at 220 because this is the value of x that makes this bracket 0, and then f of x will be 20. And I'll use the fact that I pass through the origin, so we've got f of 0 is equal to 0, which leads to a times 0 minus 2 squared plus 20 is equal to 0. So 4a plus 20 is 0. 4a is minus 20, so a is negative 5, which means that f of x is minus 5 brackets x minus 2 squared plus 20. We then have a second curve C2 with equation y is x squared minus 4. The two curves meet at the origin and at the points P and Q. And given that the x-coordinate of P is negative, we need to use algebra and show all stages of the working to work out the coordinates of P. So we've got two curves. To find the points of intersection, I will simply be equating the two. So minus 5x brackets x minus 4 is equal to x brackets x squared minus 4. I will expand both sides of the equation, leading to minus 5x squared plus 20x is equal to x cubed minus 4x, and I will be collecting everything on the right hand side, leading to 0 is x cubed plus 5x squared minus 24x. Well, we observe that x is a common factor, so 0 is x brackets x squared plus 5x minus 24, and I can further proceed with factorizing. So we've got 0 is x plus 8, x minus 3. So this means that x is 0, or x plus 8 is equal to 0, or x minus 3 is equal to 0. So we've got x is 0, x is negative 8, and x is 3. Well, we have been told that the x-coordinate of P is negative, which means that the x-coordinate of P is a negative 8. And therefore, I only need to proceed to find the corresponding y-coordinate. So y is going to be minus 5 times negative 8 times negative 8 minus 4. This gives an answer of y being minus 480, and therefore we conclude that point P has coordinates negative 8, minus 480. In question 10, we've got the curve C passing through the point P with coordinates given here. We've got the expression for f dash of x, and we are told that f dash dash of x is 0 at P, and we need to determine the exact value of k. Well, I will start by considering f dash of x, which is equal to 4 times x cubed raised to the power of a half plus kx to the negative 2. So this means that f dash of x is 4x to the 3 over 2 plus kx to the minus 2. So I've written f dash of x in index form in order to proceed into finding the second derivative, f dash dash of x. So I multiply by the power and I deduct 1 from the power, and similarly here plus k times minus 2x to the minus 3. This leads to 6x to the half minus 2kx to the minus 3, and we know that f dash dash of 2 must be 0, so it's going to be 6 times 2 to the half minus 2k times 2 to the minus 3. This leads to 6 root 2 minus k over 4, which is equal to 0. So if 6 root 2 is equal to k over 4, this simply leads to 24 root 2 being the value of k. In part B, we need to find the f of x, giving our answer in its simplest form. So I need to use integration to move from the first derivative back to the original f of x. So f of x is going to be the integral of 4x to the 3 over 2 plus 24 root 2x to the minus 2 dx. So we have replaced the k with the value of 24 root 2 we just obtained in part A. So in integration, we increase the power by 1 and we divide by the new powers. So it's going to be x to the 5 over 2 over 5 over 2 plus 24 root 2 x to the minus 1 over minus 1 plus the constant of integration c. This means that f of x is 8x to the 5 over 2 over 5 minus 24 root 2 over x plus c. I will then use the fact that f of 2 is 8 root 2. These are the coordinates of point P, which means that we've got 8 root 2 is equal to 8 times 2 to the 5 over 2 over 5 minus 24 root 2 over 2 plus c. This leads to 8 root 2 is equal to 32 root 2 over 5 minus 12 root 2 plus c, which means that c is 68 root 2 over 5. The only thing missing is a final answer for f of x. So we've got that f of x is equal to 8x to the 5 over 2 over 5 minus 24 root 2 over x plus 68 root 2 over 5.